The lone pair of electrons of nitrogen allows amines to react as a base or as a nucleophile. It can react in acid-base reactions. In the presence of an acid, your nitrogen can obstruct this proton to form the aminium ion. The lone pair is also responsible for the capability of amines to be alkylated. In this case, it will react in an SN2 manner to form this ammonium salt. The amino group in aniline is an orthopara director and forms these two products in electrophilic aromatic substitution. In the case of nucleophilic aromatic substitution, the lone pairs again are responsible for interaction with the carbon bonded to the chlorine in this case to form a substitution product. Amines react with nitrous acid and they will undergo diazotization. The reagent here is sodium nitrite and an acid such as HCl or sulfuric acid, which are needed to produce nitrous acid in situ. This active reagent can produce a diazonium salt when reacted to an amine. For the case of primary amines, this diazonium salt is unstable and readily forms nitrogen plus a reactive carbocation. Thus, this reaction is not useful in organic synthesis. Secondary amines form N-nitrosamine. Here is the general formula. Primary arylamines give relatively stable arene diazonium salts. Here is the structure. Now, in contrast to the primary alkylamines, this compound is very useful synthetically. Arene diazonium salts are used in replacement reactions. You can start from arylamines and react it with nitrous acid to form your arene diazonium salt. The arene diazonium salt can react with a variety of compounds to form new substitution products. You will notice that here copper is often involved, and these reactions are called Sandmeyer reactions. Sandmeyer reactions use copper plus salts to replace the diazonium group. For example, if you want to replace the diazonium group with chlorine, you can use cuprous chloride. If you want to replace it with cyano group, you use cuprous cyanide. Other reagents are also possible. For example, replacement reactions can be used in the preparation of this meta-substituted compound from benzene. Take note that these two halogens are orthopara directors, and yet here they are positioned meta to each other. How will you prepare this compound in typical electrophilic aromatic substitution? It is not possible. However, if you do arene diazonium salt replacement reactions, you can generate this compound. You can start from benzene using the typical nitration procedure. Now, this nitro group is a meta director and can now be used to add a chlorine atom at meta position. The next step is the reduction of this nitro group. We can use the method I mentioned earlier, thin in hydrochloric acid plus heat, to form your amino group. Now, this amino group can react with your nitrous acid to form the diazonium salt. Finally, you can use Sandmeyer reaction to replace this diazonium group with bromine to form your target compound. In reactions with aryl sulfonyl chlorides, primary and secondary amines react to produce sulfonamides. Tertiary amines do not react. In my illustration here, I use a primary amine. A primary amine will react with aryl sulfonyl chlorides in a mechanism that is very similar to the nucleophilic acyl addition-elimination reaction I mentioned in carboxylic acid and derivatives topic. So here, the lone pair of nitrogen will attack the sulfur atom. This oxygen will form a single bond, will form a double bond later, and release the chlorine as a leaving group. Eventually, you will form the sulfonamide. Now this sulfonamide is insoluble in water and will precipitate out in solution. If you add potassium hydroxide, the hydroxide group will take this proton and produce a salt. Now this salt is soluble in water. If you add HCl, the soluble compound will again precipitate in water. This series of reactions is the basis of the Hinsberg test. For primary amines, sulfonamides dissolve upon the addition of aqueous potassium hydroxide due to the formation of this salt. In the case of secondary amines, the sulfonamides remain insoluble upon addition of potassium hydroxide. If you start from a secondary amine, the product will not have this hydrogen. Instead, it will have an alkyl group. Even if you add potassium hydroxide in this case, you will not form a salt that will dissolve in water. Now for tertiary amines, they do not form sulfonamide. And if the amine is insoluble in water and you add aqueous hydrochloric acid, you will increase the solubility of your tertiary amine in water.